All right, welcome back to the deep dive. Today, we're going to try to unpack this whole machine learning thing.
Yeah,
You sent over some Wikipedia stuff,
yeah,
and honestly,
lots of it.
my brain's already a little fried.
Yeah, it's definitely a complex topic,
Okay.
but the basic idea is pretty simple.
Yeah.
We're talking about computers that can learn from data
Uh-huh.
without needing specific instructions for every single step.
Okay, so it's not like those sci-fi movies where robots become super smart and like, take over the world.
Not quite,
I'm just making sure.
but we'll definitely get to the potential implications later on.
Okay.
Think of it this way. Traditional programming
Okay.
is like giving a computer a detailed recipe
Okay.
to follow step by step.
Okay.
Machine learning is more like giving it a ton of ingredients and letting it figure out how to make a dish on its own.
So the computer is basically coming up with its own rules based on the data it sees. That's kind of freaky.
It is pretty wild when you think about it.
Yeah.
The goal is for the computer to be able to generalize from the data it's seen.
Okay.
It can handle totally new situations it's never encountered before.
Like it's not just memorizing stuff,
Right.
it's actually learning how to learn.
Exactly.
Yeah.
And that's why it's so powerful.
Okay.
We're already seeing it in things like spam filters,
Yeah.
movie recommendations, and even medical diagnoses.
It's like that whole thing where Netflix offered $1 million to anyone who could improve their movie recommendations.
Yeah, the Netflix prize.
Yeah.
That was back in 2006.
Yeah.
And a team actually won by creating a model that significantly boosted Netflix's recommendation accuracy.
Oh, wow.
That was a huge turning point.
Okay.
That really sparked interest in the possibilities of machine learning.
$1 million will definitely get people's attention.
For sure.
And, thinking about it, recommendations are everywhere these days.
Oh, yeah.
Amazon,
Well,
Spotify,
Yep.
those dating apps that think they know who I should be swiping right on. It's kind of creepy, but also kind of impressive.
Yeah. Yeah.
And how did we even get to this point? I mean, computers learning on their own.
Yeah.
Didn't this stuff start way back in the day?
You're right.
Like with
The roots of machine learning go back to the 1950s,
wow.
which is ancient history in terms of computer science.
That's like before color TV, right?
Pretty much.
I-
One of the early pioneers was this guy named Arthur Samuel.
Okay.
Back in the 50s, he created a program that learned how to play checkers.
Oh, wow.
The program actually analyzed thousands of games and eventually started making moves that were better than the guy who programmed it.
Computers learning to beat us at games.
Yeah.
That's both cool and a little scary.
Yeah, it's pretty mind-blowing.
Yeah.
Another important figure was Donald Hebb,
Okay.
a psychologist who proposed a model for how neurons in the brain learn.
Okay.
His work actually laid the foundation for some of the machine learning algorithms we use today.
So brains and computers learning from each other.
Yeah.
It's pretty trippy.
Yeah, for sure.
Okay, so we went from checkers in the 50s
Right.
to this whole Netflix prize thing in the 2000s.
Yeah.
How did machine learning evolve over all those years?
There were a lot of incremental advances,
Okay.
but one key factor was the exponential growth in computing power and the availability of massive data sets.
So basically computers got way faster
Right.
and we started collecting tons more data.
Exactly.
Makes sense.
And with more powerful computers and more data to learn from,
yeah.
machine learning algorithms were able to tackle more complex problems and achieve much higher accuracy.
Okay, so we've got this general idea of machine learning.
Yeah.
Computers learning from data without being explicitly programmed.
Right.
But are there different ways they can learn?
Yeah, that's a great question.
Okay.
And yes,
Okay.
there are actually three main types of machine learning that we need to understand.
Okay.
Supervised learning,
Okay.
unsupervised learning,
Okay.
and reinforcement learning. Okay.
Each one takes a different approach to learning from data.
All right, hit me with it.
Okay.
What's supervised learning all about?
Imagine you're teaching a kid how to identify different types of fruit.
Okay.
You show them an apple and say, this is an apple.
Okay.
Then you show them an orange and say, this is an orange.
Right.
You're essentially giving them labeled examples to learn from.
Okay.
Supervised learning is kind of like that for computers.
So you're feeding the computer data that's already categorized or labeled.
Exactly.
Okay.
In supervised learning,
Okay.
we give the computer a set of training data.
Yeah.
Where each data point comes with a label
Mm-hmm.
or a target output.
Okay.
The computer's job is to learn the relationship between the input data and the labels.
Yeah.
So it can predict the correct label for new data it hasn't seen before.
Okay, I think I'm following.
Good.
So is this like how spam filters work.
That's a perfect example.
Okay.
Spam filters are trained on huge data sets of emails.
Where each email is labeled as either spam or legitimate.
Right.
The algorithm learns to identify patterns in the email content and sender information that are associated with spam,
Okay.
and then uses those patterns to filter incoming email.
That makes sense. So it's learning to spot the red flags that scream spam.
Exactly.
Right.
Supervised learning is really good at classification tasks like that,
Okay.
where the goal is to categorize things,
Right.
but it can also be used for regression tasks,
Okay.
where you're trying to predict a continuous value.
Like predicting the price of a house based on its size, location, and other features?
Yeah, that's a classic example of a regression problem.
Okay.
You train a model on data from past home sales,
Okay.
where each data point includes features like square footage, number of bedrooms, and neighborhood, along with the actual sale price.
Right.
The model would learn the relationship between those features and the price.
Okay.
And then you could use it to predict the price of a new house that's on the market.
So it's like having a super-powered real estate agent in your computer.
Yeah, exactly.
Pretty handy.
Pretty handy.
Okay, so supervised learning is all about learning from labeled data.
Right.
What about this unsupervised learning thing?
Think of a kid playing with a big box of Legos.
Okay.
They don't have any instructions,
Right.
but they start to notice that certain pieces fit together in certain ways.
Right.
They might start grouping the pieces by color, shape, or size, even though no one told them to do that.
Okay.
Unsupervised learning is kind of like that for computers.
So it's like the computer's just exploring the data and trying to find patterns on its own.
Exactly.
Okay.
In unsupervised learning, we don't give the computer any labels or target outputs. We just give it the raw data and let it find the underlying structure or patterns on its own.
That sounds way more challenging.
It can be.
Like it has to figure everything out from scratch.
It can be pretty difficult.
Yeah?
But it's also incredibly powerful. One common application of unsupervised learning is clustering,
Okay.
where the goal is to group similar data points together.
Like if you had a bunch of data about your customers,
Right.
you could use clustering to group them into different segments
Exactly.
based on their buying habits or demographics.
That's a common use case in marketing.
Okay.
You can use clustering to identify groups of customers who might be interested in similar products or services,
Okay.
and then tailor your marketing efforts accordingly.
That makes sense.
Yeah.
So unsupervised learning is like giving the computer a puzzle and saying, figure it out.
Of a very complex puzzle.
Yeah.
With no picture on the box for reference.
Oh, man.
But that's what makes it so fascinating.
Yeah.
It's like the computer is discovering hidden knowledge that we might not even be aware of.
Okay, that's pretty cool.
Yeah.
So supervised learning is like learning with a teacher.
Right.
And unsupervised learning is like figuring things out on your own.
Right.
What about this reinforcement learning thing? That sounds kind of intense.
Yeah.
Like boot camp for computers?
It's definitely a different type of learning.
Okay.
Imagine you're teaching a dog a new trick.
Okay.
You give the dog a treat when it does something right,
Yeah.
and maybe a little scolding or a timeout when it does something wrong.
Right. Right.
The dog learns by associating its actions with the rewards or punishments.
Okay.
Reinforcement learning is kind of like that for computers.
So it's all about trial and error.
Exactly.
Like the computer tries different things
Right.
and gets feedback
Yeah,
based on whether it's getting closer to the goal.
exactly.
Okay.
In reinforcement learning, we
Right.
have a software agent
Yeah.
that's interacting with an environment.
Okay.
The agent takes actions,
Okay.
and the environment provides feedback
Uh-huh.
in the form of rewards or penalties.
Okay.
The agent's goal is to learn a policy,
Okay.
a set of rules
Right.
that will maximize its rewards over time.
Okay, I think I'm getting it. So like if you were training a self-driving car.
That's a perfect example.
Yeah.
Self-driving cars are using reinforcement learning to navigate complex environments
Wow.
and make decisions in real time.
Wow.
It's a really powerful technique
Right.
for training agents to perform tasks that require sequential decision-making.
So basically it's like teaching the computer to play a video game.
That's a great analogy.
Okay.
And actually, reinforcement learning has been used to create AIs that can beat human champions at all sorts of games, from
Yeah.
chess and go to complex video games like StarCraft.
I've seen those documentaries about AlphaGo
Yeah.
and how it beat that world champion Go player.
Yeah. It's incredible.
It's insane how much these programs can learn.
It's crazy.
Okay, so we've got these three main types of machine learning.
Yeah.
Supervised, unsupervised, and reinforcement.
Right.
But What about the actual tools and techniques? Like, what are the nuts and bolts of how this stuff actually works?
There are a ton of different models and algorithms within each type of machine learning, each with its own strengths and weaknesses. It's like a whole toolbox of different approaches.
Okay, so what are some of the key models that are being used in the real world?
Well, one of the most popular and powerful models is the artificial neural network, or ANN.
Those are the ones that are inspired by the human brain, right?
Yeah, exactly.
I've seen diagrams of them. They look super complex.
They can be complex, but the basic idea is that you have a network of interconnected nodes, kind of like neurons in the brain, and each connection has a weight associated with it. The network learns by adjusting these weights based on the data it sees.
So it's like the connections between the nodes get stronger or weaker.
Exactly, depending on how important they are for making accurate predictions. Exactly. And the cool thing about neural networks is that they can learn to extract features and patterns from the data that we might not even be able to identify ourselves.
That's where the whole black box thing comes in, right?
Yeah.
Like sometimes we don't really understand how the neural network is making its decisions.
Yeah, that's one of the challenges with neural networks. They can be very powerful. But they can also be difficult to interpret.
Right.
It's like they have their own secret language that we're still trying to decipher.
Okay, so neural networks are one big tool in the machine learning toolbox.
Right.
What else have we got?
Well, another important model is the decision tree.
Is that like a flow chart?
Exactly. Imagine a tree with branches that represent different decisions or conditions. The tree starts at the top with a root node and then branches out based on the features of the data. Each branch leads to a leaf node, which represents a final decision or a prediction.
So it's like a series of yes-no questions that lead you to a conclusion.
Yeah, that's a good way to think about it. Decision trees are pretty easy to understand and visualize, which is one of their advantages.
So you can actually see how the model is making its decisions. Unlike those mysterious neural networks.
Exactly. They're more transparent. Which can be really important in certain applications. Where explainability is key.
Okay, so we've got neural networks and decision trees. Any other big players in the machine learning world?
Yeah, there are tons.
Oh, man.
Support vector machines, or SVMs, were another popular model. They're particularly good at classification tasks. Like separating data points into different categories.
So like if you were training a model to recognize cats versus dogs.
Exactly. You could use an SVM to draw a line that separates the cat pictures from the dog pictures. Exactly. SVMs are really good at finding the optimal boundaries between different classes of data. They're used in all sorts of applications, from facial recognition to spam detection.
Wow, so many different approaches.
Yeah, there are.
It's mind-blowing how much this field has exploded in recent years.
Absolutely.
Okay, so we've talked about the different types of machine learning and some of the key models. But where is this stuff actually being used in the real world? Like, how is it impacting our lives right now?
Oh, machine learning is everywhere these days. It's being used in healthcare, finance, transportation, entertainment, you name it.
Wow.
It's quietly revolutionizing so many different industries.
All right, give me some examples. I want to see how this stuff is actually playing out in the real world.
Okay, let's start with healthcare. Machine learning is being used to develop new diagnostic tools that can help doctors detect diseases earlier and more accurately.
Like those AIs that can analyze medical images.
Exactly. And spot things that human doctors might miss. Exactly.
Wow.
Machine learning algorithms can be trained on massive data sets of medical images, like X-rays, CT scans, and MRIs. They can learn to identify subtle patterns and anomalies that are indicative of different conditions.
So it's like having a super-powered radiologist in your computer.
It is.
That's pretty amazing.
And it has the potential to save lives by enabling earlier detection and intervention.
What are some other ways machine learning is being used in healthcare?
It's also being used to personalize treatment plans. based on a patient's individual characteristics and medical history.
So like tailoring treatments to each person's unique needs.
Exactly.
Wow.
Machine learning algorithms can analyze a patient's genetic information, lifestyle factors, and past medical records to predict which treatments are most likely to be effective.
That's incredible.
Yeah.
It's like taking personalized medicine to a whole new level.
It really is.
Wow.
And it's not just about diagnosis and treatment. Machine learning is also being used to improve patient care and streamline administrative tasks in hospitals and clinics.
So it's like making healthcare smarter and more efficient on all fronts.
Absolutely. And that's just one industry. Machine learning is having a huge impact on finance as well.
Money matters.
Yeah.
How is machine learning changing the financial world?
Banks and financial institutions are using machine learning for fraud detection, risk assessment, algorithmic trading, and even customer service.
I can see how it would be useful for fraud detection.
Yeah.
Like spotting those weird transactions that scream,
Exactly.
this is a scam.
Machine learning algorithms can analyze transaction patterns and identify anomalies that might indicate fraudulent activity.
So they're like digital detectives.
That's a great way to put it. Always on the lookout for suspicious behavior. Exactly. They can also be used to assess credit risk and make more informed lending decisions.
So those algorithms are the ones deciding whether I get approved for a loan.
Well,
maybe I should start being extra nice to my computer.
Well, it's not about being nice to your computer, but it is about having a good credit history and financial profile. Machine learning is also playing a huge role in algorithmic trading, where computer programs make trading decisions automatically, often at speeds and frequencies that humans can't match.
So it's like Wall Street, but with robots calling the shots.
Kind of. Algorithmic trading has become a major force in the financial markets.
So healthcare and finance are getting major makeovers.
Big time.
Thanks to machine learning.
Right.
What other industries are being transformed?
Well, transportation is another big one. Self-driving cars are the most obvious example. But machine learning is also being used to optimize traffic flow, improve logistics and delivery routes, and even predict maintenance needs for vehicles and infrastructure.
So it's like making transportation safer, more efficient, and maybe even a little less stressful.
That's the goal. And then there's entertainment. Machine learning is being used to personalize recommendations for movies, music, and books. It's also being used to create new forms of content, like AI-generated music and art.
So those algorithms are the ones deciding what shows Netflix thinks I should binge watch.
Exactly. They're analyzing your viewing history and preferences to predict what you might enjoy.
I'm starting to feel like these algorithms know me better than I know myself.
It can be a little creepy, but it's also pretty cool. And it's not just about recommendations. Machine learning is also being used to create special effects in movies. Generate realistic 3D environments for video games, and even compose music.
It's like machine learning is becoming the ultimate creative collaborator.
In a way, it is. It's giving artists and creators new tools and possibilities
that were never imaginable before.
So healthcare, finance, transportation, entertainment. Is there any industry that machine learning isn't touching?
It's hard to think of one.
Wow.
It's really becoming a ubiquitous technology, impacting nearly every aspect of our lives in some way.
It's like the internet. You can't escape it. And it's only going to become more pervasive in the future.
Exactly.
Wow.
And that brings us to some important questions. About the potential impact of machine learning on society as a whole.
So we've explored the good stuff. How machine learning is improving healthcare, making our lives easier, and even boosting our creativity.
Absolutely.
But what about the potential downsides? Like, are there any risks or concerns we should be thinking about?
There are definitely some important things to consider. One of the big ones is the potential impact on jobs and employment.
Yeah, that's the whole robots taking our jobs thing, right?
Like, if machines can learn to do more and more tasks, what happens to the humans who used to do those jobs?
It's a valid concern. As machine learning becomes more sophisticated, it's likely to automate certain tasks and even entire job roles that are currently done by humans.
So what can we do about it? Like, how can we prepare for this potential shift in the job market?
Well, one important thing is education and retraining.
Okay.
We need to focus on developing skills that are uniquely human.
Yeah.
And that are unlikely to be automated anytime soon.
Like creativity, critical thinking, and problem solving.
Exactly.
Okay.
Those are the skills that will be in high demand in a future workforce, where machines are handling more of the routine tasks.
So we need to level up our human skills.
That's a good way to put it.
Okay.
It's not about competing with machines,
right,
but about finding ways to collaborate with them and leverage their strengths while focusing on what we do best as humans.
Okay, so jobs are one concern.
Yeah.
What are some other potential downsides of machine learning?
Well, another big one is data privacy and security.
Okay.
Machine learning algorithms rely on vast amounts of data to learn and make predictions.
Yeah.
And that raises concerns about how that data is being collected, stored, and used.
Yeah, I'm always getting those creepy targeted ads that make me wonder, how do they know I'm thinking about buying a new pair of shoes?
It can definitely feel invasive.
Yeah.
And there's a real risk that our personal data could be used in ways that we don't consent to.
Right.
Or that could even harm us.
So, like, what if our data is used to discriminate against us?
That's a big concern.
Or to manipulate our opinion?
Those are very real concerns.
Right.
We need to develop strong regulations and ethical guidelines to ensure that our data is being used responsibly.
Yeah.
And that our privacy is protected.
So it's like, with great power comes great responsibility.
Exactly. And that's why it's so important to have these conversations and to be aware of both the potential benefits and the potential risks of machine learning.
This has been really eye-opening.
Good.
It's clear that machine learning is already having a huge impact on our lives.
Yeah, absolutely.
And it's only going to become more influential in the future.
It's going to be everywhere.
It's definitely a technology that's worth paying attention to.
Yeah.
It has the potential to solve some of the world's biggest problems.
For sure.
But it also comes with some serious challenges that we need to address.
Absolutely.
So it's like any powerful tool, it can be used for good or for bad.
Right.
It's up to us to make sure we're using it wisely.
I couldn't have said it better myself.
It's like we're standing at the edge of this whole new world.
Yeah.
And we don't even know what's out there yet.
That's a great way to put it.
Yeah.
Machine learning is still a relatively young field.
Okay.
And we're just starting to scratch the surface of its potential. Who knows what kind of breakthroughs we'll see in the next decade or even the next few years.
It's both exciting and a little bit terrifying, right?
Yeah.
Like, what happens when computers become smarter than us?
That's the million-dollar question.
Yeah.
And it's one that philosophers and scientists have been debating for a long time.
Right.
But even if machines surpass human intelligence in some ways, it doesn't necessarily mean they'll be a threat to us.
So it's not like those Terminator movies where the robots turn on humanity.
I don't think so.
Okay.
But it's always good to be aware of the potential risks.
Right.
The key is to make sure that we're developing these systems responsibly and ethically with human values and well-being as the top priority.
Okay, so how do we do that? Like, how do we make sure that machine learning is used for good and not for bad?
Well, one important thing is transparency.
Good.
We need to be able to understand how these algorithms are making decisions, and we need to be able to hold them accountable if they make mistakes.
So no more black boxes.
Ideally, no.
Yeah.
We need to be able to see inside those algorithms and understand their reasoning.
That makes sense.
Yeah.
What else can we do?
Another important thing is diversity.
Okay.
The people who are developing these systems need to represent the diversity of humanity as a whole.
Right.
If we only have a narrow group of people designing these algorithms, we're going to end up with systems that reflect their biases and values, which might not be representative of everyone.
So, like, if we only have tech bros building these systems, we're going to end up with algorithms that think everyone loves craft beer and coding.
Something like that.
Yeah.
We need to make sure that the people who are shaping the future of machine learning are representative of all of us.
Okay. Transparency and diversity.
Yeah.
What else?
Education is also key.
Okay.
We need to make sure that people understand how machine learning works.
Right.
So they can be informed participants in this technological revolution.
Yeah, it's like if you don't understand how the system works, you're just at its mercy.
Exactly. Knowledge is power.
Okay.
The more people understand about machine learning, the better equipped we'll be to navigate this rapidly changing landscape.
So what can our listeners do to learn more about this stuff?
Well, there are tons of great resources available online and in libraries.
Okay.
There are introductory courses, documentaries, podcasts, you name it.
Okay.
There's a whole world of information out there waiting to be explored.
And if our listeners want to dive even deeper, maybe even consider a career in machine learning.
Absolutely.
Okay.
It's a rapidly growing field with tons of job opportunities.
Wow.
And it's not just for computer scientists anymore.
Right.
People with backgrounds in math, statistics, data analysis, and even the humanities are finding exciting careers in machine learning.
So anyone can get involved regardless of their background.
Pretty much. If you're curious, creative, and willing to learn, there's a place for you in this field.
That's really encouraging.
Good. I'm glad.
It's like machine learning is not just some abstract concept.
Yeah.
It's something that people can actually participate in and shape.
Exactly.
Right.
It's not just about computers.
Yeah.
It's about people.
Yeah.
It's about using our ingenuity and creativity to create a better future for everyone.
I love that.
Yeah.
Okay, so we've talked about the potential benefits and the potential risks of machine learning.
Yeah.
And we've talked about what we can do to make sure this technology is used responsibly.
Right.
But what about the big picture?
Right.
Like, where do you see machine learning going in the next 10, 20, even 50 years?
It's hard to say for sure.
Yeah.
But I think we're going to see some truly mind-blowing advances.
Okay.
I think we'll see machine learning revolutionize fields like healthcare, education, and transportation.
Wow.
I think we'll see AI systems that can design new drugs, personalize learning experiences, and even solve complex problems like climate change.
So it's like machine learning is the key to unlocking a whole new level of human potential.
I think so.
Wow.
It's like giving us a superpower.
Yeah.
But instead of wearing capes, we're writing code and building algorithms.
That's a great way to put it.
Yeah.
And like any superpower, it comes with great responsibility.
Absolutely.
Yeah.
We need to make sure we're using this power wisely and ethically.
Okay.
The future of machine learning is in our hands.
Well said.
Thank you.
And on that inspiring note, we'll wrap up this deep dive.
Okay.
Thanks for joining us.
It's been a pleasure.
Yeah.
Until next time, keep those algorithms learning and those questions coming.